This notebook, we're going to explore reading in very large files with Pandas, and then kind of also look at specifying data types and a little bit of issues about differences in locale of how data might be represented in, say, Europe versus the United States. So to demonstrate reading in large files, we are going to take a data set that is a data set of all car accidents in England between 1979 and 2004. And as we demonstrated in the previous notebook, we have a lot of data. This is a very large data set. So we're only going to read in 20 columns from the original data set. But we are going to read in all the rows. And as we go through this, let's run this. Again, this is large, so it's going to take a little bit of time. And so I'm going to, I don't need to pause. So what we read in, if we look here, we read in about 6.2 million rows of data. This is a far larger file size than a standard Excel file will be able to read in. And we will return to this, this file in class when we look at mapping, interacting with maps to display data. Okay, so as I mentioned before in a prior video, Pandas can determine for us the data types in the columns. This can take time and memory. And so if we are really concerned about efficiency and we know what our data types are in each of our columns, we can make our reading process in both faster and more efficient by specifying the column types with a D-type keyword and look at the documentation to see how to do that. We can also tell it a little bit about where the data came from. So one kind of, in my mind, still kind of entertaining example of this is that the Europeans and the Americans use a different thousand marker. So in the United States, we use a comma to separate 1,000. So if we're writing 1,000, we might 1,000. Whereas in Europe, we have the reversed role of the period and the question mark. So the question mark is the decimal marker for in Europe, and so it's a international world. Data might be coming in from a variety of sources, and data might be represented in a way that's different from the locale that we are at. And so one of the things that Pandas lets us do is specify what the 1,000 separator is in our data. So here we're going to take a completely non-medical data set. It's a list of elevations in the various states. So we have what the highest elevation is and what the average elevation is. And we're going to read in, specify which columns we're going to read in. And in the first run, we're not going to specify what the 1,000 separator is. So let's read this in. And if we look at what data type is stored for average elevation, we see that it doesn't recognize it as being a number, and so it has kept it in its default format, which is a string. If we tell Pandas that our data is going to have a comma as a 1,000 separator, then you can already see that how it's displayed. So it's displaying them without comma separators, and if we query what data type it is, we see that it's been converted to a NumPy int64. So again, if we know something about our data, we can help Pandas out in reading it and save time and subsequent processing on our part.